In this video, we are going to look at the fifth law of indices called the negative law of indices. So let's have a look at what we already know using the second law, the division law. I'm going to write x to the power 4 divided by x to the power 6. Now using the division law, we would look at the same base, which they have, and we would subtract the powers. Subtracting the powers leaves us with x to the 4 minus 6, which means we're left with a negative indice because 4 minus 6 is negative 2. Looking at this, if I was to do expanded factor form, x to the power 4, so would look like x times x times x times x, all divided by x to the power 6, which is obviously this with an extra 2 x's. Now, you can do some cancelling here. And when you cancel things that are multiplied together, you're left with 1. So that's 1 times 1 times 1 times 1. Now, I've now got no x's on the bottom, but I do have the number 1 because 1 is created when you cancel. But on the denominator, I'm left with 2 x's times by itself, leaving me with x squared. Thus meaning that x to the power negative 2 is the same as 1 over x squared. I'm now going to write the general form to this rule, which is going to be in a purple box for you to copy down. Alright, now let's have a look at an example. I'm going to do quite a few examples here. So the first example, evaluate the following. Evaluate, remember, means work the answer out and leave it as best as you can. So let's have a look at 5 to the negative 2. Applying the rule, which is up at the purple box, the base is 5 and we have negative 2. So let's just plop that in. We've got 1 over 5 squared would be a rule just straight over. So 1 over 5 squared. Now we can evaluate this and we can write that as a proper fraction because 5 squared is 25. So the answer is 1 over 25. Now looking at this, when you apply the negative power on this particular instance, it's just to the negative 1. Therefore, this means that each of these is to the negative 1. So I'm going to do this the long way. You will eventually just be able to go, oh, I can flip it. But let me just show you the long way so you have the understanding. So both the power is applied to the numerator and the denominator. Now let's look at this. This is 1/3. And we're dividing, so divide line, by 1/5. Remember, when you're dividing fractions, you can flip the second fraction or find the reciprocal, and it turns into a multiplication problem. Now, multiplying fractions means multiply all the numerator together. 1 times 5 is 5, and multiply all the denominator together. 3 times 1 is 3. Now, if you have a look at the result, what you can see is that when anything is to a fraction is to the negative 1 power, you can literally flip or find the reciprocal of that fraction, and you can see I've got 5 over 3. All right, second example. Let's have a look at writing some of these with positive indices. So A, what we have here is 5x to the power negative 6. X is the base and is to the power negative 6. So it's this bit here that we apply the negative law to. Now let's go on to the 5. The 5 is a whole number. So what we've got here is 5 multiplied by 1 over x to the 6. Now we can rewrite that together, because it's just multiplying a whole number by a fraction, as 5 over x to the power 6. Let's look at this one over here. I'm going to do this one similar to the example above. This numerator is 1 over x cubed, divided by the denominator, which is 1 over x squared. Now, we can just turn this into a multiplication problem like above. So 1 over x cubed multiplied by x squared over 1 gives me x squared divided by x cubed. You'll also notice that if I do 2 take away 3, I'm left with 1 over x. Now let's have a look at if we'd use the second law of division. Negative 3 take away negative 2 is the same as going negative 3 plus 2. To give you negative 1. So that would leave us, if we were to use the second law, with x to the negative 1, which is exactly the same as our answer down here. Alright, so we're going to simplify writing your answer with positive indices. That word there with positive indices. This is how all of these should be simplified. You should never leave an answer with a negative indice. So looking at this question, this looks quite daunting, but it isn't really. We're just going to tackle it a bit at a time. And remember, we've got fractions that we're multiplying. So applying the raising a power of a power law to this one, this gives us p to the power 8 and q to the power 4. And I'll just leave the denominator the same for now. Looking over on the right, raising a power of a power, I'm left with p to the negative 6 over q to the power 3 times 3 is 9. Now I'm going to multiply all the numerator and all the denominator together. It's not the only way to do this. There are other ways of doing this. This is my choice. So I'm going to use the first law of indices with the base p here. I'm going to add the indices. 8 plus negative 6 leaves me with p to the power 2 and q to the power 4. On the denominator, I'm going to look at the q's here. I'm still with 5p to the negative 3. Adding these leaves me with q to the power 12. Let's cancel the q's now. I'll worry about the p's in a minute. So we can see we've got 4 of the q's on the top and 12 on the bottom. So there's going to be more on the bottom. So I'm left with p squared on the top, 5p to the negative 3. And on the bottom, I've got q to the power 8. As 4 take away the 12 gives me the negative 8, so I know it's on the bottom. Now the last step is to deal with the base p. Now I'm just going to go aside from this for a moment. You can use the division law here and you'll notice that 2 minus 3 gives you 5, so we're left with p to the power 5 on the numerator. But here's why. We've got p squared on the top divided by p to the negative 3, right? So I've just isolated this bit. P squared is divided by 1 over p cubed. That's what it means using the negative law of indice. Now again, division of fractions, I can take the reciprocal and turn it into a multiplication problem. Now looking at this, we can add the indices through the multiplication law. So we're left with p to the power 5 over 1. That means that when I simplify this, I've got p to the power 5 on the numerator over 5 q to the power 8.